let's now look at our techniques of drawing inverse sine or inverse trig graphs. Now, the key here is to be able to look at, well, what would our domain and range be for these situations? Now, remember that when we take sine of some angle, it's going to give us a value between -1 and 1 when we get something out. So when we're reversing this and taking inverse sine, we can only take an inverse sine of something between -1 and 1 because that's what the y value is in the function of sine of x would be. So whatever inverse sine we're taking, we can only take between the inverse sine of 1 and those values have to be between -1 and 1. Now if that's x on 2, well, that will change the values that x can take, obviously, because only this part has to be between -1 and 1. So it's x on 2 there. So x could be between -2 and 2. So when we're going to graph it, we can go from -2 to 2 for our domain. Now, what that gives out then, to make it a function, remember that for sine of x, we restricted our domain to between -pi on 2 and pi on 2. So that was our restricted domain for sine of x to give us a function. So the inverse sine of x, the range would be between the -pi on 2 and pi on 2. So inverse sine of x on 2 has to be between that. Now, if we have a multiplication of 4, factor of 4 there, multiplying by all that, so only that part has to be between -2 and -pi on 2 and pi on 2. But multiplying by 4 means our range will be increased by a factor of 4. So that's where our range is going to be. So that's what we're looking at. So our domain and range, once we're going to be able to do that, remember as well, and when x is 0, its inverse sine is 0, it's still going to go through 0, 0 in this case. So when we graph it, it's still going between 0, 0. It's just a case of -2 to 2. Remember, first quadrant is going to be positive, fourth quadrant negative, and it's going this time between -2 pi and 2 pi there. So that's what that graph looks like, and that's how we've got to treat it. We've got to look at, well, what's our domain going to be? What's our range going to be? What factors have we got to put into place? What does our graph normally look like? And then what are the manipulations that have to be taken into account? So 3 cos, inverse cos of 2x. So remember, when we take inverse cos of a function, again, has to be between -1 and 1. It's cosine of some angle will give us only something between -1 and 1. Reversing it, that we have to look at that. So that means if it's 2x, our domain now gets restricted between -1/2 and 1/2. So we've got to be considerate of that. And now, again, when we looked at our range of, and our domain of our restriction for our domain before of cosine of x, we said, well, the restriction of the domain had to be between 0 and pi to still include the origin. So again, our range for an inverse function will be between 0 and pi. So multiplying that by 3, well, the 0 still multiplies by 3, it gives us 0, but pi becomes 3 pi when we multiply by the factor of 3. So cos of inverse cos of 2x would be between 0 and pi, but 3 cos inverse cos of 2x goes between 0 and 3 pi. So that's where it starts to look at. Please ignore that part, because the graphing program kept going with it. It didn't cut it off for me, but there's from 0 to 3 pi. Remember, it's symmetrical, so if it's going 3 pi, it's going through 1/2 pi for 0. So you can put the 0 in as well, like when x is equal to 0, what's y, and it'll be 3 pi on 2. We see the -5 to 0.5 there, so -1/2 to 1/2. So again, for 10, well, our domain doesn't really matter for that one because it's all real x. We can throw any value in there, not a problem. But our restriction on our domain for tan of x was between -2 pi and pi. So our restriction for our inverse tan becomes between -2 pi and pi. And when we take a multiplication factor of 2 there, so that would multiply every term by 2. So that's where the halves go, and we get -pi to pi. And then we can draw it up. Put our asymptotes in. They're ugly asymptotes. Sorry about that. They could have done better. But our curve still has that basic shape going through the origin, and there was no restriction on domain, and it was just our restriction on our range that's going to come in for our inverse function because we restricted our domain before. So remember these rules for the next lot of problems. So work we've done in the trig functions earlier. And can we use those ideas to play around with some of these problems? Well, if we're going to look at sine of 2 lots of the inverse tan of 3 on 4. So again, go back to this idea that sine, let inverse tan of 3 on 4 be alpha. So again, if we draw up our graph there, our triangle, if we've got an angle alpha, tan's the opposite on the adjacent. So our hypotenuse would be 5. So sines of alpha is 3/5 and cos of alpha is 4/5. So again, if that's all this part is alpha, then that's really just taking sine of 2 alpha, which is 2 sine alpha cos alpha. 2 lots of 3/5 times 4/5 gives us 24 and 25. So there's how our manipulations can come into play with this one. Cosine of 2 inverse sine of 2/3. Well, again, this one's not as pretty. But again, let alpha be sine of 2/3. So there's our alpha. Opposite on the hypotenuse. So by Pythagoras, it's √5. So sine of alpha is 2/3. Cos of 2 alpha could be written as 1 minus 2 sine squared alpha, which we can put in to get 1/9. So we can play with it that way. Or you could have used any version of cos 2 alpha to manipulate and use √5 on 3. It would still work for you. So in looking at this one, this is a nice question to do if you know to draw the diagram. If you don't draw a diagram, this one's reasonably hard to put into place. But if we look at this one, and we look at inverse sine of 4/5. So again, if we let alpha be inverse sine of 4/5. So if that's alpha, the opposite on the hypotenuse would be 4/5. But if beta is inverse cosine of 4/5, well, that beta would be the other angle there, because that's the opposite on the hypotenuse. So we can see that those two, that all forms the one triangle. So those descriptions there form the right triangle, form the triangle nicely. So from that, alpha plus beta, well, because it's 90 there, the alpha plus beta must equal pi on 2 as well, because it's the angle sum of the triangle. When if alpha is inverse sine of 4/5 and beta is inverse cos of 4/5, we can see the two of them add together to give us pi on 2. Very nice. The one's doable, but made much easier when we consider our diagram and do it in a graphical form. And that's the idea. We're understanding what the nature of an inverse function is, and we're able to manipulate and solve it much easier when we draw those diagrams and get our domains and range correct.